Okay, so like I said, we're picking up where we left off with 3.1, problem 15. Now, this is sort of a follow-up to that summary we did. Remember, we said that in the coordinate plane, any point in quadrant 1 has both coordinates positive. Any point in quadrant 2 has a negative first coordinate and a positive second coordinate. In quadrant 3, both coordinates are negative. In quadrant 4, the first coordinate's positive, the second coordinate's negative. And of course, points on either axis are considered to not be in any quadrant. Sorry about the bump. My dog just ran into me. So, in which quadrants can the point be described be located? The first coordinate is negative, the second coordinate is positive. That has to be quadrant 2. The first and second coordinates are positive, has to be quadrant 1. If the first coordinate is positive, well, that doesn't tell us everything we need to know. This coordinate, if all we know is the first coordinate's positive, this could be in either quadrant 1 or quadrant 4. And that's as specific as we can be if all we know is that the first coordinate is positive. The second coordinate is negative. Again, we only can conclude that the point is in quadrant 2 or quadrant 3. If the first and second coordinates are equal, that means that they must both either be positive or both be negative. So those such points could be in quadrant 1 or quadrant 3. And again, it doesn't really matter if you use Roman numerals or not for the quadrant numbers. Now, this is an interesting statement. The first coordinate is the additive inverse of the second coordinate. So that means that the first coordinate is, well, let's talk about what additive inverses are. So, excuse me. Well, that's all right. So, 3 has an additive inverse of negative 3 because 3 plus negative 3 equals 0. So look at that. Positive, negative. Quadrant 4 has points like that, so could be that this point is in quadrant 4, some point where the first coordinate is the additive inverse of the second coordinate. But let's say something like, let's start with a negative 5. The additive inverse of negative 5 is positive 5, since those numbers add to 0, and I see that points in quadrant 2 have that property. So if you have an ordered pair where the first coordinate is the additive inverse of the second coordinate, the coordinate you are discussing must either be in quadrant 4 or quadrant 2. All right, let's move on to the next set of problems. Let's see, this is, I believe, the next page. So now notice we are going to find the coordinates of points A, B, C, D, and E. This is sort of thinking backwards from when we were plotting the points given their coordinates. So A, I'm just going to write A, and then I'm going to put a parenthesis, and I see that it has first and second coordinate 3. B has first coordinate 0, second coordinate negative 4. C has first coordinate negative 5, second coordinate 0. D has first coordinate negative 1 and second coordinate negative 1. And E has first coordinate 2, second coordinate 0. Now it would be a good exercise for you to look at these coordinates and determine which quadrants they're in, if any, without looking at the picture. Let's look at number 22 here. We'll do the same. We'll use the same notation, letter, and then parentheses. First coordinate's 4, second coordinate is 1. B, first coordinate is 0, second coordinate is negative 5. C, first coordinate is negative 4, second coordinate is 0. D, we've got first coordinate negative 3, second coordinate negative 2. And E, we have first coordinate 3 and second coordinate 0. Now at this point I'd like to remind you that I keep using the words first and second coordinate because the first axis and second axis is what we're talking about. These do not have to be x and y axes. That's very important as you move on into your further mathematical career. I know many of you are going to take college algebra, and there are all sorts of situations in a college algebra setting where these axes are not x and y, and it's very important that you can think about them in that way. So please keep working on that. And I am going to stop the video here. So the next video will pick up on problem number 23.